Hello students, welcome you all to the solution session for the subject Fluid Mechanics, branch of Mechanical Engineering, GATE 2023 questions. Moving on to the very first question of Fluid Mechanics. Air density of 1.2 kg per meter cube with kinematic viscosity 1.5 into 10 power minus 5 meter square per second flows over a flat plate with a free stream velocity of 2 meter per second. The wall shear stress at the location 15 mm from the leading edge is tau W. What is the wall shear stress at a location of 13 mm from the leading edge? The question is from boundary layer theory. Option A, tau W by 2. Option B, root 2 tau W. Option C, 2 tau W. Option D, tau W by root 2. So, first, when we are going to solve this, we need to check for Reynolds number. U infinity L by nu. U infinity is how much? Velocity 2 meter per second. 2 into length, how much meters? 30 mm from the leading edge is asking you. That will be 0.03 meters by nu. Nu is kinematic viscosity 1.5 into 10 power minus 5 meters square per second given to you. Solve this, how much you are going to get? We will be getting around 4000. Reynolds number is around 4000. So obviously whenever it is less than 5 into 10 power 5, what type of flow we call it as? Laminar flow. We call it as laminar flow. So the wall shear stress in case of laminar flow, if you people remember, it will be inversely proportional to your distance. That is, if you take a plate at a distance of 15 mm and is asking you to find at a distance of 30 mm. So obviously this is how the profile look like. Tau W2, tau W1, right? So obviously we'll write tau W2 by tau W1 is equal to root of x1 by x2. Tau W2 by tau W1 will be is equal to root x1 is 15, x2 is 30. So tau W2 by tau W1 will be equal to root 1 by 2. Tau W2 is equal to tau W1 into root 1 by 2. Tau W2 equal to tau W1 by root 2. So check for the answer. Option D should be your right answer for the given question here. Option D will be the right answer. Moving to the next question. Consider an isentropic flow of air with a specific heat of 1.4 through a duct as shown in the figure. The variation in the flow across the cross sections are negligible. Flow conditions at location 1 are given as follows. Pressure at inlet 100 kilopascal, density 1.2 kg per meter cube, velocity 400 meter per second. Duct at the cross section of location 2 where A2 is equal to 2 times A1. A1 denotes the duct cross section at location 1. Here all the specifications are there. And given statement about the velocity V2 and pressure P2 at location 2 is true. Option A, U2 less than U1, P2 less than P1. Option B, U2 less than U1, P2 greater than P1. Option C, U2 greater than U1, P2 less than P1. Option D, U2 greater than U1, P2 greater than P1. So obviously, the step 1 for finding out here, when the cross section duct is given in this way, right? So here the area is A1, density rho 1, pressure P1 with velocity U1. At the second end, it is P2, A2, U2, rho 2. So obviously, the type of flow you need to identify. Is it a supersonic flow or a subsonic flow? So basically when we are talking about this, Mach number plays a very important role. which will be U by C1, where your C1, the velocity of sound, will be under root gamma R T1, right? So P1 equal to gamma 1 R T1, where T1 is equal to P1 by rho 1 R. P1 100 by 1.2 into 0.287, which will be temperature when you calculate 290.36 Kelvin. Now C1 is equal to gamma 1.4, R, your universal gas constant, 287 into 290.36 Kelvin, where you will end up with an answer of 341.56. So the Mach number will be 400 divided by 341.56. Your answer is 1.017. So obviously U2 will be greater than U1 and supersonic flow, right? P2 will be less than P1. The diverging, there is a diverging duct of the nozzle, and we have clearly mentioned that Mach number is greater than 1. So obviously supersonic flow. So U2 greater than U1 and P2 less than P1. Moving to the next question. The figure shows two fluids held by a hinged gate. The atmospheric pressure is PA, which will be around 100 kilopascal. The moment per unit width about the base of the hinge is dash kilonewton meter per meter, rounded off to 1 decimal place. Take acceleration due to gravity is 9.8 meter per second square. So obviously the given diagram is there. When I draw a free body diagram like thing for this, this is the plate. The height is h1, density rho 1. It is h2, this is rho 2. He has given clearly 1000 kg per meter cube and 2000 kg per meter cube. Right? So obviously, when you talk about Pascal's law or submerged body, there will be a triangular shape like this, right? So when I take this as A, B, C, here there will be something called D and E, and that will be dropped down. The force will be acting somewhere at a hydrostatic pressure force here. There is a height you need to know. Now this way again F2 will be acting somewhere. So obviously this height, that will be 2 by 3 from the bottom, a standard value. The total height here is 3, right? So F3 will be acting, F2 will be acting, F1 will be acting. So when you calculate this heights, because this is a hinge where the body is totally to revolve about 7 by 3, 1 and 2 by 3. So from this pressure distribution diagram, if I want pressure F1, half AD into DE, right, into some width. Obviously we take it as unit width if not given, that will be half 1 into 9810. So from there F1 will be 4905 Newton, 4905 Newton, right? Now F2, what happens when we are talking about F2? This is the condition, right? There is one rectangle and there is one, and obviously it is totally taken as rectangle only, right? So D, E, B, F into some width DEBFC, DEB, right, and F. DEBF will be this condition and width of 1. So obviously 2 into 9810 into 1, which will be around 19620 Newton. This will be F2. F3, which will be triangle EFC, half EF into FC into width of 1, half into 2 into 39240. From here you'll get 39240 as your force. So location of force we need to know, right? Location of force. When we are talking about this location of force, it will be 2 by 3 at a height of 1, F1. Obviously I told you here 2 by 3. That will be 2 by 3 meter. This equal to F1. F2. 1 plus from the top 2 by 2, which will be 2 meters. So pressure P1 will be rho. Oh, sorry. We need to find F3 also, right? F3, 1 meter plus 2 meters into 2 by 3, right? From top, which will be 7 by 3 meters. Location. So pressure at 1 meter depth. Rho 1 G H1, 1000 into 9.81 into 1, which will be 9810. So from here DE will be 9810, BF will also be 9810. All are Newton per meter square only, right? So pressure at a depth 3 meters, rho 1 GH1 plus rho 2 GH2, 9810 plus 2000 into 9.81 into 2, 9810 plus 39240, which will give rise to 49050 Newton per meter square. So BC will be equal to what? BC. BC will be equal to BF as, this is F, right, plus FC. So obviously F1 will be equal to 3 minus 2 by 3, which will be equal to 7 by 3 meter. F2 1 meter. F3 2 by 3 meter. So when we are talking about moment about the hinge, what is going to happen? Force into perpendicular distance. F1 into 7 by 3, F2 into 1, F3 into 2 by 3, right? F1 into 7 by 3 plus F2 into 1 plus F3 into 2 by 3. So F1 is how much? 4905. F2 19620. F3 39240. So substitute it, you should get a value of 57225 Newton meter or 57.22 kilonewton meter per meter. So here you will be having around 57.22. Got it? So this will be your answer for the given question. Moving to the next question. The velocity field of a certain two-dimensional flow is given at v equal to x comma y, where k x I cap minus y j cap. K is 2 per second constant. X and y are in meters. Assume gravitational effect to be negligible. The density of the field is 1000 kg per meter cube and the pressure at the origin is 100 kilopascals. So pressure at location 2 meters, comma 2 meters in kilopascal is asking you. Generally, if we are talking about two-dimensional flow, pressure at two particular positions, let it be P1 plus half rho V1 square is equal to P2 plus half rho V2 square, right? So he's asking you at 2 comma 2. So initially origin will be 0 comma 0 and the next point will be 2 comma 2. So V is equal to K into X I cap minus Y j cap. V1 is equal to 2 into 0 minus 0 initially, which will be 0. P1 will be 100 kilopascal, right? That will be 100 into 10 cube pascal. Now at location 2 comma 2, what happens? 2 into 2y minus 2j. So when we talk about this, we will be 4i minus 4j. V2 is equal to, let it be 2, root of 4 square plus 4 square root of 32. That will be 4 root 2. Simple, right? Now take this and apply in your standard generalized equation here. Now that will be 100 into 10 cube plus half rho 1000 into 0 V is equal to P2 plus half 1000 into 32. From here, try to get the value of P2. Try to get the value of P2. You should get around 84,000 Pascal, which will be 84 kilopascals. Which will be 84 kilopascals. So the answer in integers will be 84 kilopascals. Moving to the next question. Consider a unidirectional fluid flow with a velocity field given by v x comma y comma z comma t with u x comma y into I cap. U of 0 comma t is 1. If the spatially homogeneous density field varies with the time, rho of t is equal to 1 plus 0.2 e power minus t. Value of 2 comma 1 is rounded to. Now, when we talk about the continuity equation, rho dou u by dou x plus rho dou v by dou y plus rho dou w by dou z plus dou rho t by dou t will be equal to 0. Clearly in the question we can see that u equal to 0, w equal to 0, rho dou u by dou x plus dou p or dou rho by dou t will be equal to 0. What is rho given to you? Rho of t is equal to 1 plus 0.2 e power minus t. When you differentiate it, obviously what you are going to have? 1 plus 0.2 e power minus t dou u by dou x plus dou by dou t of 1 plus 0.2 e power minus t, which will be equal to 0. From there, 1 plus 0.2 e power minus t dou u by dou x minus 0.2 e power minus t will be equal to 0. 1 plus 0.2 e power minus t dou u by dou x is equal to 0.2 e power minus t. Dou u by dou x will be equal to 0.2 e power minus t by 2. 0.2 e power minus t by 1 plus 0.2 e power minus t. Right? When you integrate it to get u is equal to 0.2 e power minus t by 1 plus 0.2 e power minus t into x plus c. U of 0 comma t, if you are going to take, it's 1 when c equal to 1. U is equal to 0.2 e power minus t by 1 plus 0.2 e power minus t into x plus 1, substituting back. So he needed at 2 comma 1, right? So at u of 2 comma 1. So what you are going to get? 0.2 e power minus 1 by 1 plus 0.2 e power minus 1 into 2 plus 1. So u of 2 comma 1 will be 1.14 meter per second when you solve this above equations. 1.14. When you round it off, it will be 1.14 meter per second. This will be the answer for the given question. Moving to the next question. An explosion at a time t equal to 0 releases energy E at origin in space filled with gas density. Subsequently, a hemispherical blast wave propagates radially outward as shown in the figure. Let R denotes the radius of the front of hemispherical blast wave. R follows a relation R is equal to K T power A E power B rho power C. K is dimensionless. Value of component A is. So when you are taking this as an hemispherical things, E and this let it be T time period. E is nothing but the release of energy. Rho is the density. Okay. So when we talk about the dimensions here, R radius, which will be L, T is time period T, E energy. What will be the energy release energy formula here empirically? M L square T power minus 2. Rho density kg per meter cube, which will be M L power minus 3. Basic fundamental units are M, L and T, right? Dimension analysis question this is. So total variables, how many you got? Total variables are 4. Number of pi terms. Number of pi terms. 4 minus 3, which will be is equal to 1. So from here I'll write R equal to T power A, E power B, rho power C. L is equal to T power A, M L square T power minus 2 power B, M L power minus 3 power C. Now compare them. You will get A minus 2B is equal to 0. Next, 2B minus 3C. 2B minus 3C equal to 1. B plus C should be equal to 0. So from here, A is equal to 2B. 2 times minus C, because B equal to minus C, no? Minus 3C will be equal to 1. So obviously minus 5C equal to 1, C equal to minus 1 by 5. B equal to 1 by 5. A equal to 2 into 1 by 5, which will be 2 by 5. R relation K T power 2 by 5, E power 1 by 5, rho power minus 1 by 5, which will be K T power 2 by 5, E power 1 by 5 by rho power 1 by 5. So obviously A is nothing but 2 by 5, which will be 0.40. Is asking you exponential component of A, which will be 0.4. By this, we have completed the questions of fluid mechanics of Mechanical Engineering 2023 GATE paper. Hope you people have understood. Thank you, students.